Hi, this is Measurement and Fairness. This is joint work with Hannah Wallach, and I'm Abigail Jacobs. This is for the Conference on Fairness, Accountability, and Transparency 2021. So I want to begin with this idea that measurement is everywhere. And what I mean is that what we are generally interested in, what underlies all of our socio-technical systems, are these unobservable theoretical constructs, things like creditworthiness or risk to society, toxic language, pro-social behavior, even fairness. And that furthermore, these are inherently unobservable. So to measure these unobservable constructs, we necessarily operationalize these constructs with measurement models, whether we do so explicitly or not. And this is not just a pedantic language talk, because when we operationalize these constructs, we're reflecting and encoding our social, our political, our cultural values. And when we obscure this process, we miss the opportunity to reflect on how those are being embedded and what potential harms can emerge. This is especially apparent when we look at the measurement process directly. Again, usually this is obscured within the machine learning pipeline, but I want to just focus on this setup here. So we begin with a construct, we operationalize it some way, we assume that this is how the construct is reflected in the real world, and then we are able to take measurements from observable attributes of the world. This is crucial because many of the sort of fairness-related harms that we actually care about either arise from mismatches between different theoretical understandings of our constructs, or between a mismatch between the construct that we believe we're operationalizing and the operationalization itself. Fortunately, we actually have tools, we have construct reliability and validity to actually help us interrogate this process, to help diagnose, mitigate, prevent these kinds of harms. And so I want to present a few examples to think about how we are making these assumptions within this measurement process, again, whether we explicitly acknowledge it or not. So beginning with maybe a simple example, let's think about this unobservable theoretical construct of height. So that can be our construct. And I'm going to assert and say, I assume that there's some latent variable h that influences the observable properties that are my height. So that's my operationalization of height. It's a very simple model. And then I might say, use a ruler and take measurements. There might be noise. What if it's a day where my hair is extra big? What if I'm wearing shoes? I might start to think about like what's going on inside of this process or what I really mean by height or who it applies to, when. But this lets us sort of break apart where these assumptions are happening and where different types of, say, errors might creep in or potentials for harm. Moving to a more social example, socioeconomic status, or SES, is commonly thought about across the social sciences, and it's our sort of social and economic opportunity, it's our standing. It really affects how we exist in the world, but one way we might think about operationalizing it is, say, with income. And of course, income is its own construct that we take measurements of as operationalize and take measurements of as well. But we might have just sort of represent SES with income. And we might actually call this using income as a proxy, where actually it just turns out that proxies are just very simple measurement models. So again, we've just got this very simple measurement model that we know what SES is, it's income, and so we can take measurements of income, and those are measurements of SES. So simple measurement models, but that includes all proxies. Then for, teacher effectiveness, we borrow the example of the Education Value-Added Assessment System, EVAS, which we'll return to. And there, the assumption is, there is this latent construct, inherently unobservable, teacher effectiveness, and we're going to operationalize that as some latent variable t. The EVAS system asserts that this can be modeled with a multivariate response model. And furthermore, that actually this is just entirely driven by student scores. So that means from student scores, we can then infer teacher effectiveness. Again, we're laying out the assumptions here so we can then explore them after. A very familiar example, but just to put it in this framework, the COMPAS recidivism risk models. There is this inherently unobservable theoretical construct that we might have ideas about what this is actually trying to represent. COMPAS assumes this is some latent variable, this risk of recidivism, and that this could be represented by this type of these scores from this regression model that use things like past criminal history to represent that risk of recidivism. And then these estimates are treated as that risk. Again, we'll return to these assumptions. And then finally, I want to borrow an example from the healthcare world where there are risk assessment tools to try to get at patient benefit. So in this case, thinking about trying to get at how much a patient would benefit from enrollment in something like a high-risk healthcare management program. So here the assumption is those with the greatest care needs will benefit the most from enrollment in this type of a program. And in practice in healthcare systems widely, at least in the US, these future care needs are typically operationalized as care costs, where needs and costs need to be comparable. And so then you can, you can estimate future costs and treat those as future estimated needs. So now I want to use this opportunity to tease apart our assumptions and get at how we can take advantage of this measurement process to think about what assumptions we're making, how they're useful, how we engage with them. So I want to start with this idea of reliability. And this is really about, with our measurement model, are we capturing something, or is this just noise? So this is roughly analogous to the concept of precision in statistics, as in the inverse of variance. So we don't want to, in the case of, say, test-retest reliability, sort of rerun the model and get wildly different results. We see this in practice with things like EVAs. But this also includes things like out-of-sample prediction. And if I give the model a similar data point, am I going to recover a similar kind of answer, or what kind of robustness do I have in this way? One instance where this came up was in the UK, where Human Rights Watch uncovered that a benefits system basically varied in what it predicted your income was based on when you enrolled. So it was aggregating from monthly income. So depending on when you were paid in the month, it was giving wildly different answers for what estimated income was. So people were being denied benefits because the system was not reliable across time. And so now I want to spend some time on this idea of construct validity, this umbrella term, where we synthesize these traditions for across the social sciences and a number of different communities in a way that we think is most productive for the FAccT community. And so we'll go through 7 different types. I'll walk through some examples. And I want to begin with an easy one, face validity. So this is roughly, is this plausible? Do we believe that this is? This is just a first pass. Maybe SES and income, that sounds reasonable. We can move on. Lower income barista, higher income CEO, maybe different SES positions. So sounds fine. Move on, pass go. But maybe we could pick a really unreliable model, like an EVAS model that gives a 6 1 year and a 96 the other for the same teacher teaching similarly. We might say, okay, that seems like, we know it's not reliable, and that doesn't really seem like it's capturing something about effectiveness. So we can say maybe it's not facially valid, and maybe we should start over. Moving from that was our sort of initial sniff test. Here we have, okay, are we actually capturing the construct that we intend to be capturing? And so There are a few ways to think about this. One is thinking about, is there theoretical agreement about this underlying construct in the first place? So in the case of fairness, we know that there are necessarily going to be conflicting understandings, and we'll return to that later. But we want to say, even if there are conflicting theoretical understandings, here's the theoretical understanding that we are choosing to operationalize, and then we can evaluate that in more of a substantive or structural sense. And so we can say, here is my understanding of what this construct is. Does my operationalization capture all of those aspects? So, for instance, my model of SES using income, maybe I want to include something like wealth or education. And so maybe my understanding of what SES is incomplete, or maybe my idea of teacher effectiveness includes something other than test scores. Just a thought. And so then this gives us a way to say, okay, we have this understanding of teacher effectiveness, and this is what we've operationalized. What are we missing? Convergent validity lets us do a quantitative comparison and say, do our measurements of this construct match other measurements that we believe of this construct? So this can be used to reassure us, yes, we get sort of similar results to what another one does. We can use it to qualitatively debug. So, my SES measure might be correlated with one from the National Committee on Vital and Health Statistics, but they include wealth and occupation and region, and maybe I should include those because I'm doing poorly on certain segments of the population. On the other hand, this can give us a false sense of security if we're correlated with, we're using a risk assessment tool like Compass, and it's correlated with other risk assessment tools that are built on flawed assumptions, then we should not necessarily be so confident just because we have this kind of convergent validity. Discriminant validity, on the other hand, lets us look at, are there other constructs that we are potentially confounding what we're looking at? Or for constructs that we expect to be related, are we sort of seeing them as related in the right ways? So with SES, this might be sort of difficult because it sort of shows up in every aspect of our lives. On the other hand, we might turn to the example, say, of patient benefit. So there, I want to point to this work by Obermeyer et al. That found that these future care needs were, their results were showing these sort of interesting correlations with race, which made it seem that those with comparable past care needs actually have very different health statuses. And what that meant, or what that was reflecting, was that there were these different underlying differences in access to healthcare. And so what was actually being learned was these racial disparities in health, that those with less access, therefore perhaps lower past costs, seem to have less needs. And so this was actually a way that this disparity was getting reinforced in this practice. So that was sort of more about constructs and relatedness in another way. Predictive validity lets us think about, for things that we didn't tell our model about, are we sort of able to do well? So if there are things that I think are related to my construct, so if I think like weight is related to height, I could say, do my measurements of height relate to weight in some expected way? For SES, if I think that's related to purchasing behavior, I could look at that and say, does my model of SES, these income measurements, do those tell me something about purchasing behavior, or vice versa? Again, this is using things that are sort of outside the model. So in a similar vein, Obermeyer et al. Looked at different kinds of medical conditions and procedures that the model didn't explicitly know about, but were able to get at these racial disparities in health needs that were being obscured by past differences in healthcare access. Very related to predictive validity is hypothesis validity, which really just says, is this a useful measure for creating knowledge? So this could be, again, very overlapping with predictive validity, but maybe, SES and purchasing behavior isn't that exciting, but maybe I want to ask, what is the relationship between SES and health outcomes? And so I could do all sorts of tests and sort of recover important results. Or perhaps I could use a weird example and say, here's the set of college students. Their reported income is quite low, but they seem to have quite good access to healthcare, access to wealth, access to these other types of markers of SES. And so it seems to be that there's a mismatch between what I would say about them based on income versus what I'm actually observing about these health opportunities. Finally, there's this really sort of important notion that was brought in starting in the 80s of consequential validity. And this really gets at, this sounds like it's a normative thing, but really it's about how these measurements shape the way that we understand the construct itself. And this is partly shown by the fact that we often use the same word for the construct we're representing and the thing that we have operationalized it as. And this shows up in a few different senses. One is through things like Goodhart's law, Campbell's law. Once a measure becomes a target, it ceases to be a good measure. It also, this can show up because, once encoded, that just is what that construct means. And it can seem objective. That's just what the risk is, or the effectiveness is. That's just what crime is, and so on. And so this feedback loop is actually crucial to think about, because it means that we're actually changing what that measure means when we create it. And so there's this great quote by Hand that measurements both reflect structure in the natural world and impose structure upon it. And so that means that to understand the measure, the first place to understand that we have that validity, we actually need to think about these downstream consequences and these kinds of feedback loops. So I want to just now return in closing to fairness, this weird type of construct. That I first want to start is, it's an essentially contested construct. For millennia, we have known that it's context dependent. There are conflicting theoretical understandings, and we're not going to solve the one true understanding of fairness. But I want to assert that we still operationalize it. And so we should still accept this and use this to acknowledge, here's the values that we're encoding, here's our theoretical understanding of fairness, here's our operationalization of that theoretical understanding, and we can assess the degree to which those actually are aligned. And then we can argue about those, but we shouldn't obscure the fact that we're often arguing about values when we're talking about different operationalizations, and we're really excluding many of those affected if we are sort of masking our discussions of values in perhaps technical language. And so just to cover a few aspects of the substantive nature of fairness, it could be that our understandings of fairness include notions of justice. And if we do want that, that's certainly a threat to content validity, where understandings of fairness don't include this aspect of justice. And regardless, it's certainly important for thinking about consequential validity. If we say that a system is fair, or this is a fair machine learning tool, a fair machine learning result, or guaranteed fairness, that sounds like fairness is being guaranteed. And if that doesn't match my understanding of fairness, that feels like there's a real opportunity for fairness-related harms. Another instance where this shows up is in disagreement operationalizations between individual and group fairness, again, masking what values are underlying each of these. And then just to unpack those, individual fairness, we're thinking about similar individuals being treated similarly, but often we're trying to capture really inherently individual, subjective, individual experiences, which again sort of face this essentially contested nature with threats to, again, content and consequential validity. Group fairness, again, we see something similar, different types of measures being reflecting different theoretical understandings, but being discussed in terms of operationalizations. And these are often done through demographic factors about constructs that are themselves essentially contested. And so, again, we see the same measurement process with the same measures affecting society in the way that we expect. So finally, measures are more than a creation of society, they create society. Let's say measurement is everywhere. Harms emerge from mismatches in the measurement process. And this is so often obscured in machine learning systems. And finally, construct reliability and validity help us interrogate this really often obscured process to prevent and mitigate harms. And so, thank you. This is Measurement Fairness, and here's some related work.